Welcome everybody after the lunch. So hopefully you enjoyed it, and yeah, we'll have the good moments during our presentation. And so, should we start?
Yeah, okay. So, Mika, go ahead, just introduce yourself.
Yeah, so welcome everybody. Thank you for choosing this presentation. And yeah, my name is Michał Jura. I'm an OpenStack developer, and with me is...
I'm Flavio Castelli. I'm engineering manager for the containers team at SUSE.
And for this presentation, we are going to talk about the OpenStack and Magnum project, and with subtopic as Kubernetes as a service for everyone.
Okay, so nowadays there are a couple of changes that industry is facing. So we have to react quickly to lots of demands from our customers, from our users. All these requirements have forced us to look into new ways to ship our code faster, to do quick iterations of our code. So because of that, we are also looking closely into using the cloud, like the public cloud or a private cloud, to scale out, to respond to peaks from our customers. And there is a new trend which is about microservices. So with microservice architecture, it's easier to enforce all this, to achieve all these goals. So to deliver tools faster, to scale out faster, and all of that. However, it's not so easy to do that, okay? Because we come from an old way of dealing with production environments. Where we dealt with machines. Now, instead, we want to shift our focus and to manage applications, not focus on machines, just to focus on the application that we want to deploy and focus just on them. So Kubernetes is a container orchestration engine. So containers, as you probably know, they are really helping with these microservices architectures. But if you want to manage all these containers in production, then you either have to create something from scratch, or which is not going to be fun, or you have to look into a container orchestration engine. For us, Kubernetes is the best way to do that because it's portable. It doesn't force its own directives. So once you have your container and you're running that on top of Kubernetes, it's really easy to move it around. It's really easy also to get the container and to deploy that with Kubernetes because you don't have to change that too much in order to use Kubernetes. Kubernetes also is friendly with legacy applications. So it's unreasonable to think that everyone is going to switch to microservices for now. You're still going to deal with applications which are not designed with this architecture in mind. And Kubernetes makes this transitioning easier because it's friendly with them. It's really open. There's no vendor lock-in. So you can really, once you are using Kubernetes, there are several different offerings for Kubernetes. So it's not vendor lock-in. And Kubernetes itself, it's really pluggable. It has different components inside of it. So for example, depending on the topic, it has different solutions. So for networking, Kubernetes, for example, proposes its own view of networking, but then how it is done, it's entirely up to you. There are different drivers out there, and you are free to choose which one to use. And that applies to several aspects, even to the container engine that is used. So for example, you all know Docker as a way to start containers, but there are other ways to start containers, and Kubernetes can allow you to choose between all these different ways to start containers. Once you have Kubernetes deployed, you stop to worry about your infrastructure, the machines, you focus on the application. That's because Kubernetes, for example, takes care of healing. So if your application is not working properly because there was some incident in production, then Kubernetes will try to restart the application somewhere else and make sure that you always have your application up and running with the directives that you imposed. You can even reach some sort of autonomous systems where you automatically scale your application depending on the load that it has. So for example, there is a peak, and your Kubernetes notices that, it will automatically scale this application to a certain level that you chose. Like, let's say it goes from 10 to 50, and then when the peak is over, it will downscale back so that you really have a better usage of your resources. Containers, as you know, are all about taking out the max from the system that you have, and Kubernetes is really helping you with that. And also, Kubernetes is an opinionated solution, which means that it tackles different problems. It has its own way to solve these problems, like networking, as I said before, like storage, for example, like secrets, and it goes even further. So if you are into these fast release cycles, you are probably already looking into blue-green deployments, which means like we are actually going to show a demonstration about blue-green deployments later on, so we will show that later on. The architecture is really flexible, as I said. You can swap out and swap in different components. But talking about the architecture, this is how Kubernetes looks like. So Kubernetes, a Kubernetes cluster, is made basically by 3 types of roles. So you have etcd, which is a distributed key-value storage. It's where the status of the cluster is stored. Then you can have an arbitrary number of etcd servers. For HA reasons, it's recommended to have at least 3 of them in production. Then you have 1 or more master, depending on your HA requirements. The master is running 3 Kubernetes-related processes. The master is basically the brain of the cluster. On the master, you run the scheduler, which takes care of figuring out where a certain container that you want to run is going to be located. It takes care of making the decision based on different parameters that are, and different statistics that are taken live from the system. You have the API server, which is basically the entry point of the cluster. So all the tools that you use to interact with Kubernetes, they go through the API server, and also the worker itself, they talk with the master through the API server. And then you have the controller manager. The controller manager is in charge of making sure that your desired state is reflected on the cluster. The desired state is something like you declare that you want to have 5 instances of this web application running at any time. So the controller manager makes sure that this is matched in reality. So if one container dies because of whatever reason, then the controller manager will take care of starting a new one. On the right, you can see the worker. You can have as many workers as you want. On the workers, you can see that we have a Kubernetes-related process called kubeproxy. This deals with Kubernetes networking, which is another concept. There is a dedicated talk about that, just to give you a perspective about the complexity. There is the kubelet. Well, it's not so scary, but networking usually is. Kubelet is a process which takes care of coordinating the actual container engine. The container engine can be Docker, can be something else, and is what is going to start the actual containers. You can see there is a pod there. Pod is a concept of Kubernetes itself. A pod is a group of containers that are really tied together. It's up to you, the developer, or the operator, to decide that some containers have a so tight relationship that they need to run inside of the pod. When running inside of the pod, certain isolation features of containers are deliberately removed. For example, all the containers inside of the pod, they have the same IP address. These can lead to really interesting scenarios and deployment patterns. For example, you can have a web application written, I don't know, in Rails, in Ruby. You're using a web server to run it, like Puma, for example. And you don't want to expose Puma. That applies also to Node.js or Python or whatever. You don't want to expose that web server straight to the internet, to your customers. What you usually do is to put something in front of it, like a reverse proxy. For example, it could be Nginx or whatever else. So with a pod, you can have your developer take the application, put that inside of its own container, and then you can have someone else, like operation, create a container for Nginx. And then you put the 2 of them together, and being inside of the same pod, they have the same IP address, which means that, as you do on bare metal on your laptop, you can configure Nginx to expose the Ruby on Rails application running on localhost, because it's the same host. So it really simplifies the deployment, and it also allows to have a better reuse of your containers. This is unique to Kubernetes, this pod model. Looking at the higher level, you can see that here we have a web application running. It's guestbook. It's exposed to the internet with guestbook.com. All the internet traffic goes through standard load balancers, and then the load balancers, they will redirect the traffic to any of the worker inside of your cluster. On all the workers, the web application is exposed on a port, which is the very same port. It's always the same across all the workers. So all the requests for guestbook.com, they get redirected to one of these ports on any of this container. And it's really interesting if you want to know more about how it works. It's really interesting that this is always going to work. If a load balancer points the request to this node, which is not running the blue container, this is still going to work because of the networking model of Kubernetes, which will automatically redirect the request from here to there. But for that, just join my other talk about networking in containers. So Kubernetes deployment. Kubernetes deployment, as we have seen, it requires an etcd cluster. It requires a worker. It requires some master. It requires a network fabric to join all these pieces together. It requires a load balancer to expose the application, as we have seen, and it requires a lot of efforts from you. Okay, that's true. That's true. I'm going to be honest. So Kubernetes is really a pleasure to be used from a user point of view. It's also a pleasure to be used from an operator point of view. If you are administering a Kubernetes cluster, it's really, really nice, but it's really a pain to deploy. And that's also why a lot of people, they are scared about Kubernetes complexity. And for example, they go to public offering on the cloud where with a single click, you can get a Kubernetes cluster up and running. For example, Google has a really good offering of Kubernetes. And a lot of people, they are scared about setting up Kubernetes. They are not scared about administering or using it. They are scared about the setup. And so they resort to a public cloud. But we want to change that. And it's possible. The first step is done by Upstream itself. Upstream is working on an easier way to deploy Kubernetes. There is a kubeadmin tool which is being worked upstream. It's in alpha state, so it's really, really the beginning. There is also some work to deploy Kubernetes using containers and to deploy Kubernetes with Kubernetes itself, just to scare you a bit. But I think there is a better solution which is ready right now. And this solution is to take OpenStack and democratize Kubernetes, right? Yeah.
So from one side, we have already ready private cloud framework, which is called OpenStack. And from the other side, we have this new awesome technology for scheduling applications and orchestrating it, which is called Kuberenetes. So right now, we can fit together, combine together these two technologies, and we can really easily say that this is a perfect solution for everyone, and everybody can use it and deploy it using the OpenStack. So how is it possible? So in one of the OpenStack release, which was called Liberty, we introduced a new component service, which was called Magnum. Magnum is the containers as a service, new service, and it's introducing new APIs and new components to the OpenStack board. So with Magnum, we can use different Linux images to deploy the Kubernetes. Of course, for us, we will show how to do this with the SLAS, but we can also do this with OpenSUSE or some different Linux images. And of course, it integrates the main components which were already mentioned by Flavio, so like the Kubernetes, Docker, Flannel, and is also using the OpenStack components like the Neutron, Glance, Cinder, Nova, and for example the Barbican or Keystone. So how does it work? So Magnum provides the Kubernetes cluster isolation for OpenStack projects. So it's the really good tool for creating, orchestrating the OpenStack resources and launching the nodes using the HIT, we can really easily, for example, duplicate our network configuration environment. So we can have this same network setup for our development environment, for beta, alpha, and for productional environment. This will be everything maintained by the Kubernetes overlay network. And we can, of course, deploy multi-clusters for one project, and each project can have the multi Kubernetes clusters as well. So, of course, we will be talking about the Kubernetes, but Magnum can be also used for deploying the different containers orchestration engines like Swarm or Mesos. Some of you probably know them already. And which is also really cool for this project. For example, once when we will deploy the Kubernetes cluster, we will still be able to operate and to communicate with the Kubernetes cluster using the native clients like the kubectl or Docker. So let's look a little bit on the architecture of this project. So as I said, on the controller node, we are starting new services, one is called Magnum API, and the second Magnum Conductor. So the OpenStack user can communicate with the Magnum and operate on different objects which are related to the Kubernetes, like the base, which are called the clusters, which nodes, pods, or services or replication controllers. And these requests will be passed to the Magnum Conductor, and Magnum Conductor will use the special driver which was related to the Linux distribution. And this driver is implemented as a HIT template, and the HIT template is the orchestration component for OpenStack to create our cloud resources. For example, we can create the volumes using the storage backend. We can, for example, create a network for a Kubernetes cluster. We can choose our image, which is supposed to be used for deploying the Kubernetes. And at the end, of course, all the Nova compute will take care about launching the virtual machines for us. And of course, as I mentioned, the Magnum is using the special image, and this image has already installed, should have installed the packages called Cloud Init, which will take all the metadata from the OpenStack and other packages related to the Kubernetes or to other CEOs. And yeah, from the OpenStack point of view, Magnum is launching two types of the virtual machines. So one type is the Kube Masters, which are controllers for the Kubernetes cluster. And these instances are running the services for a Kubernetes, like a controller manager, scheduler, or the API server or etcd services. And the other type of these instances are kube minions. So for us, those instances will be used for hosting the containers. And for us, those instances will be workers for our application. So, and when we will have the ready Kubernetes clusters and we will deploy our application on it, we can always make it available to the internet using also some network from OpenStack and use the load balancer resource from the Neutron and make it available to the internet. So yeah, why the Magnum is so good solution? So of course, everybody can deploy in a really easily way its own Kubernetes cluster. It will take only a few minutes, what we are going to show. Everything will be done automatically, of course. And we can always auto-scale our environment. So, for example, we can just on demand make the request that we would like to have not 5 workers, but we, for example, we need to scale up our environment and to start something like 5, 10 nodes more. And each of them, they will be automatically configured and joined to the already existed Kubernetes cluster. So, and at the end, we will be able to start our containerized application on it. And as I said, we can still expose this service to the internet using the neutron. And why this two combination? I mean, why we should recommend to use the Magnum with the Kubernetes as a containers orchestration engine. So this is because it's based on the experience from one of the biggest internet company, which is called Google. So they were struggling with the same problems for many years. And right now they decided to share their own experience with the community, open source community, and they started to develop this Kubernetes project. So once when we will, for example, adopt our application to the microservices and to the containers environment, every time we'll have really easy way to deploy it. So, for example, we'll be able to deploy it on OpenStack or on many other public platforms or cloud platforms. So yeah, we will be only taking care about only developing our application. So, for example, all the problems from the past about maintaining and administrating the traditional infrastructure will go away. So I heard that one bottleneck. So right now there is only one bottleneck for Kubernetes, and this is the OpenStack. So it means that Kubernetes is better way prepared for deploying the big data deployments, for example, with thousands of nodes, and this will be working really good. And yeah, of course, we can still always to choose between the virtual machines and the bare metal machines. It depends, of course, on which level of security we would like to stay. What is the future for this project? So yeah, we have been started already to work on the bare metal support because many of customers, they already requested for it. I'm not sure, but we have already demo running the CAS91065 on the ARM architecture with the Kubernetes. So we done already the first point about the supporting ARM architecture. We are preparing for also supporting this solution on S390. We would like to have also auto-scaling for the Magnum deployment. So right now we have this auto-scaling feature in Kubernetes, but we would like to also connect the Magnum deployment with, for example, ceilometer and heat, where we can always use some thread shots and to automate auto-scaling up the whole infrastructure.
If I can add something, this is one of the features which excites me the most, because right now, as I said at the beginning, Kubernetes can automatically scale up its workload. So if you have a web application and it has a peak, it will spawn up new instances of this web application on its own to respond to this peak. But what happens when everything is saturated inside of Kubernetes? Like you have already reached the maximum of all the workers that you have. There's no more scaling at this point. And this is where the integration with OpenStack is really exciting, because then you can tell OpenStack to start scaling the Kubernetes infrastructure. So as soon as Kubernetes is maxed out, or as soon as it approaches the limit, Kubernetes could start, OpenStack could start to provision new workers, add them to the cluster of Kubernetes, make the cluster of Kubernetes even bigger, and by doing that, give more ceiling for your application. So this is really autonomous systems.
Yeah, we would like to also make sure that all the deployments done by Magnum will be also fully high availability. I mean that right now the availability is implemented already in Kubernetes, but what will happen with, for example, one physical compute node will go down. So this is which we are working on it currently. And yeah, we would like to also support other containers engines like the Rocket or RunC. And the newest feature, which will be implemented for the next release probably, will be something like rolling updates. So we will be able to upgrade the containers orchestration engine. In our situation, it will be Kubernetes with no downtime. Okay, let's speed up a little bit. So this, what we said, is bringing us to some new to the summary of this presentation. So that right now the Magnum is something like Magnum project is making the OpenStack much more complete. So because previously we had this framework for orchestrating making the infrastructure as a service. With the Magnum, we can just add the new component for deploying the applications. So we can, for example, create our own library of the applications and to use it. So this is also about deploying the projects which are totally aware of about the containers topology, and this is also making the OpenStack as a first-class citizen for containers. And of course, what we are going to show now, this is also about helping developers with their work. But can you? Okay. So we have a demo which we prepared. I'm sorry for the little bit quality.
It's a blurry because of a projector, of a beamer.
Yeah. So right now we are presenting the Crowbar project, which is which in SUSE we are using for deploying the OpenStack. So we added the new component, Barclamp proposal, which can be used for deploying the Magnum project. And after this, we have this ready OpenStack deployment. Yeah. So right now we just switch to the OpenStack Horizon, where you can just watch what the cloud resources we have available. And we will, for our demo, we'll be using the SLES Magnum-based image, Magnum SLES-based image. And for deploy, for example, the Kubernetes, we need to only create the Bay model. It's the template, and which is collecting the parameters and the recipes how we supposed to deploy the Kubernetes cluster. So right now we are choosing the Magnum, we are choosing the image, we are choosing also the flavor. So for we have two types of flavors, for a master node and for a workers. So these two instances can be deployed with another size. And we, of course, choosing the size of the volume which is supposed to be mounted for a workers. And this volume will be dedicated for containers data. So, of course, about the network, so we need to only choose the network driver and choose the floating network. And that's all. In our example, we will be using also some local Docker registry. And yeah, once we'll create the Bay model template, we'll be able to deploy as much Kubernetes clusters as we want, just for example, clicking one button and telling that this Kubernetes cluster we will have with the one master node, and for example, at the beginning we would like to start it with 2 minions.
So what is happening now? You created the bay, which is a Kubernetes cluster.
Yeah.
What happens behind the scene?
So yeah, Magnum Conductor is using the hit template, and it's creating the full cloud stack for our deployment. So right now we have you can see the bubbles, and each the bubble is representing some other cloud resource, which is supposed to be normally created manually by the operator. And right now
what is the shield, for example?
Shields are representing the security groups, and the security groups, they are collections of the firewall rules for the masters and the minions.
So if I have multiple tenants and I create one bay per tenant, they are going to be isolated.
Yeah, always.
Secure. Okay.
Yeah. So always we will have the different security groups for different clusters. So right now we can see that master node is booting. So we see that services are starting, and it's almost ready. So right now the image, the instance is starting the cloud init service, and this service will take the metadata from the OpenStack, and this data will be used to configure Kubernetes services.
So all the pain that I was mentioning before about configuring Kubernetes in terms of services to start, configuration files, packages, and all of that, this is taken away right now, exactly?
Yeah, so exactly in a couple seconds. So let's look once again on the hit stack, what is going on next.
I think it's also interesting to say that you're running this video was recorded on your equipment at home, which was not real production cloud, right?
Yeah. So this was recorded on my development machine. So
how much time it takes to create the bay on your virtualized cloud?
Almost a couple minutes, 2 minutes, I think. So it's always taking as much as is needed to launch new virtual machine. So right now we can see that, for example, already the hit orchestrator created for the Kubernetes cluster volumes, which are already mounted to the minions, and these volumes, this storage will, as I said, will be used for Docker containers data. So on the network topology, we can see that all the nodes are already created. They have its own network. They are connected, and they are already also using some router, which making possible to connect to the internet from inside. Yeah, to, for example, download some packages or to install some Docker images. So right now, let's look once again on the console from the Kubernetes minion instance. So it was already
and again, it goes.
Yeah.
So it configures other types of services and other things all automatically.
Yeah. So yeah, and I think that we are almost done with our Kubernetes cluster.
A funny story. There was one of our customers we were talking about, and they said it took me 8 days to figure out how to deploy Kubernetes, and then he saw this video in 3 minutes on a virtualized cloud, not real cloud.
Yep.
Yeah, everything worked in 2 minutes.
Yeah.
Imagine what on a native cloud,
yeah,
what can be done.
Yeah. So when we will have deployed the Kubernetes cluster, we need to only take the API address of it, and we can start to work on this. So
yeah, so now from this point on, it's plain Kubernetes. It's a vanilla Kubernetes. You can use your usual tools. If you want to know more about these tools, there's a workshop about that. So you can see the cluster is made by 2 nodes, and now we are going to do a deployment. So we're going to deploy one of the Kubernetes 101 applications. This is a guest book, which is composed by a web application and a Redis for the database. But since we want to do things in a better way, inside of this demonstration, we will show that we're going to deploy a Redis master process, and then we will deploy some Redis slaves so that the data of Redis is spread between different nodes, so you get some HA. So now the master is being created inside of its own container. It's taking some time because it's downloading the container, and it's downloading that from the internet, so you should upgrade your connection at home, I think.
Yeah, definitely.
And then we create a service. The service is what Kubernetes uses to expose a daemon to all the pods inside of the cluster. So now the service is created, and we create a slave controller. So this is how we do HA with Redis, not real HA, but okay. So we defined everything, and now Kubernetes is going to take care of creating all the required pods. You can see that there are the pods on the top. Down there, this is the service output. The replica controller that we define is basically what enforces the desired state. Again, there is a talk about demystifying Kubernetes, which talks about that. Basically, you describe how things should look like, and then Kubernetes would take care of making that happen. So now we have one master running, one slave running. We didn't want to rely just one master and one slave, so we said we want to have two slaves. So one slave is still being created. Kubernetes is automatically figuring out where to place all these containers for you. So it's really fire and forget. You don't have to care about that anymore. Now all the pods are running, so we can get, for example, the logs of the master. The really nice thing is that you do that straight from your laptop. You don't have to figure out where the container is running, SSH into the virtual machine, and then get the logs. Everything is straight from your laptop. You can do the very same thing, for example, to find yourself inside of a running container to do debugging, like doing an SSH. It looks like that, okay? Now we are creating the web application. The web application is called front-end controller. It's exposed, but this time it's exposed in a different way because it has to be exposed also to computers which are outside of the Kubernetes cluster. So if you remember, in the beginning when I showed you the really high-level overview of Kubernetes, you had the cluster, and then in front of the cluster you had the load balancer. So for people on public clouds, Kubernetes has an integration which basically takes care of talking with the infrastructure as a service to provision the load balancer. But when you are on OpenStack, there is the integration with OpenStack is not yet there. This is one of the areas that we want to expand. So in the meantime, you can use the load balancer as a service of OpenStack to expose this service, which is exactly what you're doing right now.
Yeah.
Exactly.
So yeah, we use the load balancer agent from the Neutron to make our application available in the internet. So what we have to do only, we have to create a load balancer pool. We have to create a virtual IP, which will be assigned to the load balancer pool. We are, of course, choosing the algorithm or load balancing method. Right now, we are choosing the round robin. And we are assigning also the floating IP, I mean the external IP, which will be where our domain of the application will be assigned. And after this, we have to only choose which workers, which nodes are workers, and we have to pass the port which was already gave us from the Kubernetes cluster.
So this is all manual, unfortunately, right now. But as I said, we want to contribute with a better integration so that Kubernetes can take care of that automatically when running on top of OpenStack, as it does on other clouds. So now everything is running. We just have to point our browser to it, and this is the web application running.
So there is a domain my app SUSE.de. So this is the guest group example. So this is the web application which is using the Redis master. It's writing to the Redis master. Redis master is replicating the data to slaves, and from slaves this data is
can also be read from the web application. So for write operation, all the write go to the master. For read, it can go anywhere. Now we want to do something more. So we want to change the application. So there is a new rollout. So we do a change of the code. We do a rebuild of the image. So we create again a new version of the same image, this time with version 2. This version 2 includes the change we just made. And now we want to do a deployment. Well, we want to do the deployment without affecting the live website. So here Kubernetes again can really help us with a deployment feature. So the deployment feature of Kubernetes is this one. We're doing a rolling update of the web application. That means that right now Kubernetes is spinning up a new instance of the image. And as soon as the new instance is up and running and working properly, it will remove an older instance, okay?
From the load balancer.
From the load balancer itself. So depending on where in the meantime, everything is working, and depending on where the load balancer will redirect you, you can see either the old application or the new one, but everything is working in the meantime. So Kubernetes keeps adding a new instance and removing an older instance until production is running only new instances. So this is something that is called also blue-green deployments, and it's something which is already built into Kubernetes, and as you can see, it works pretty smoothly. So now the demo keeps waiting for everything to be deployed, but I guess we can go back to the presentation, right? Because we're running a bit out of time.
Yeah, okay. Go.
And it's time for questions. We have 10 minutes for questions, something like that.
So yeah, this presentation was mostly about showing you the new way of taking care about the applications. And as we see, there is a really big hype behind Kubernetes and OpenStack. At least everybody right now, they are trying to move their workloads. They are trying to build their applications within the microservices and to switch to these two new technologies. So as we could show up, I think that because when you switch to the Kubernetes templates manifest, you can really easily operate with your application with completely no downtime. You can really easily autoscale it, and you are getting for free this high ability to your application. So, yeah.
I hope you liked it. Do you have any questions? Yep.
Is it 6 or is this in 7?
It's 7. The question was about, is Magnum inside of SUSE OpenStack Cloud 6 or 7?
Yeah, there was on the presentation, because I was recording this on my development environment, and there was only one image not replaced yet. So the graphic will come from our UI team.
The Magnum module will be native.
Yeah, it will be as a native, as a...
Can you repeat the question just for the recording, please? Sorry.
Okay, the question was if the Magnum will be embedded, like?
High availability.
Ah, okay. Yeah, so as all the OpenStack services, because they are based on the HTTP, and mostly there's a really easy way to load balance all these services. Right now, the Magnum is possible to deploy also with the HA flag, so it's possible to deploy it on the cluster. So yeah, the
end of the room. Yeah.
How do you see microservices against function as a service? Because nowadays function as a service or backend as a service or serverless computing.
Yeah, like Lambda from Amazon. So the question, how do you see microservices as opposed to
how do you see
Lambda?
these are going to be competing or collaborating
I think they can collaborate. I mean, there is no such a thing as a serverless infrastructure. So Lambda itself is backed by computing, and container. I think there are also prototypes in the open about using containers as a way to power stuff similar to Lambda. So I don't think they are competing against each other. I've never used Lambda, to be honest. I read something about that. I don't know how easy it would be to do debugging and this sort of things. So unfortunately, I don't.
OpenStack is from open source, similar product of Lambda. I'm just trying to see how these are going to be shaping up down the line in the industry.
Okay, Adam.
How does Kubernetes react if the compute node on which a Kubernetes node is running fails? How does it? So say if you were using the compute node HA feature and it restarted that Kubernetes node on a different compute node, would that be okay?
So the question is, what happens when
one compute node will go down? Yeah. So yeah, during, for example, the development process, I was doing exactly the same tests, for example, because I wanted to, for example, update my node. So with having, I was having, for example, working the Kubernetes cluster with some application on it, and I was just switching the nodes just like this. So once the Kubernetes noticed that one worker is down, he started automatically, so he put the flags that this worker is down, and started to move the containers to other workers already. So
what about Kubernetes master? If a master is down?
So if a master goes down, the Kubernetes cluster is still operational. It just isn't able to react to events, like if a node goes down, or if a container dies, all the intelligence to react to this event is on the master. So if the master is down, there is no recovery. As soon as the master is up again, the master will automatically figure out that something happened while it was away, and it will start the healing process.
We can always deploy, of course, the Kubernetes cluster with many
Many masters.
Yeah, and this will prevent from the some crashes and some downtimes as well. Yeah.
Going back to the failure case of the worker, is it backed by shared storage? Because if it was, then when the compute node HA would bring it back up, then wouldn't it try and bring it back up in the same state as when it failed, which would still be having containers running on that?
So when you run a container, you don't really care about storage unless you specify that the container has persistent storage. And if it has persistent storage, then the storage is already somewhere else. Kubernetes is already storing that somewhere else. So if the container, the data which is on the compute node is just the Docker images. So this is the only thing which is there. And if they are missing, and a container is requested to start from an image that is missing, then it will automatically be fetched again.
But I was talking about if it's not missing.
If it's not missing, it will be just reused. But a container, a running container, if a container is running and the node goes down, and then for whatever HA magic, I don't know, it's brought up again, the container will still be dead. And its data will be on the disk, but it won't be reused anymore. And this is by design, so it's not a big deal. Yep?
How do you go about upgrading the workers? You mentioned that the worker goes down, you can restart it. How do you roll up an upgrade with the container infrastructure running?
So Magnum, as a project upstream, is working to providing a solution for that. We are evaluating different upgrade strategies. The easiest one would be to just deploy a new worker with a new version, and then just drain the old worker. Draining a node is just it just means to Kubernetes that this node is going to be put offline for maintenance reason. It's a bit more graceful as to unplug the power cord. So once you put a worker in drain mode, Kubernetes will automatically start to restart containers running on that node somewhere else. And then once the node is empty, you can destroy that. And here you have done an upgrade. This is a strategy, but we have also other ideas on our mind. We are evaluating them.
Yeah. Any concerns with migrating the containers from one old worker to the new worker and having it still function the same way?
So first of all, maybe it's better if we clarify the concept of migrating a container. Containers are not migrated as VMs. When you talk about migrating a VM, you imagine something like a live migration or something like that. This is not possible for containers. Well, there is some work, but it's not yet supported upstream by Docker. The main reason, one of the reasons because of that is actually people using containers don't care about live migration that much because there is this whole thing about stateless containers. So there is no state inside of a container. So to migrate a container, it means you kill it and you start a new instance somewhere else. If you have a stateful container which has data that has to be made persistent, then with Kubernetes, you can just say this container needs a volume. A volume is, you can imagine that as a network share where data has to be written, and then all the data is automatically offloaded somewhere else. So when you do the migration, you just kill the container, the data is not lost because it's somewhere else, and when the new container is provisioned on another machine, Kubernetes will make sure that the data which is needed by this container is already on that node. So you don't lose the data. But you don't do things like migrating processes and that.
Yeah, so as an addition to what Flavio said, during the 1 week ago, during the OpenStack Summit, there was already some presentation from IBM where the engineers, they started to demonstrate how the possible live migration for containers also can be done with the Linux kernel. So it's already possible, but the functionality is not yet implemented. But Linux is giving all the features to for example, to freeze the process in the kernel and to import it somewhere else and just
My
start
concern
it.
is more of importing the container even if it's off. You mentioned that you can use Rocket, Docker, different container technologies, but even different versions of Docker we know have issues running the same container. So if you have Kubernetes which supports a pluggable, swappable environment, is there anything that's really built into the technology that allows you to take one container, shut it down, and then run it on Rocket versus Docker, or a newer version of Docker versus the older, like 1.9 versus 1.10? Is anything like that built in, or because that's the main concern when it comes to upgrading the workers or modifying the workers in the underlying technology, is that some of the containers won't run on those new workers. How are you supposed to go and figure that out?
So first of all, we want to focus right now we're focusing on Docker. So I don't expect to have a hybrid deployment of Kubernetes with some workers using Rocket, some workers using Docker. It would be, technically speaking, it would be even possible. It would be even possible, for example, to have different workers using different versions of Docker itself. And then with Kubernetes, you could I'm just dumping my brain, you can even add some traits to nodes like labels, and you say this worker provides Docker 1.8, and then you can, for example, say that a certain container has to be scheduled only on nodes which satisfy this requirement. But to do the thing you described, I think it's something that you have to do beforehand and figure out if your application is really behaving the same way between different releases of Docker.
Kubernetes should be selected in terms of the label.
Yes, because it's really flexible. You can define labels to identify, you can attach attributes to a node. It's like in this morning, the keynote we've sold, where you say this is a triangle with parameters. You can associate additional information to a node of Kubernetes, and this is taken into account by the scheduler if you really require these constraints to be satisfied.
Yeah, and as I know, there will be always backward compatibility in Kubernetes, at least one version before, so it should be also supported. Yeah. Okay.
Any other question? Okay. Thanks a lot.
Thank you.